We've mentioned that there's two kinds of quantities. Scalars don't need direction. That's things like temperature, time, mass, pH in chemistry, just an energy. Things that are complete with just the number and the unit, those are scalars. And then there's these things called vectors, quantities that aren't quite complete unless we do have the direction. Like if we talk about how fast something's going. 2 meters per second doesn't completely describe it. If we say it's going 2 meters per second west, that nails it. Then we know everything about that thing's, how quickly it's moving. Now in motion, it gets a little bit dicey, so I'm trying to choose my words carefully. When we talk about motion, we usually describe two things: how far something's moved and how fast. For both how far and how fast, there's scalar and vector versions of how to talk about that. For how far, the scalar version of how far is something called distance. This is what the step counter built into your watch or phone would measure. This is what your car odometer would measure. We don't really care about the direction that the car is driven. We just want to know how far it's gone. As I'm trying to get more fit, I don't care about the direction I walk. I just want to make sure I get all my steps in. The scalar version of how far we call distance. There's a vector version of how far. It's called displacement. It's more if you needed to really define where something was relative to its starting point. We don't use it too often in everyday life. Maybe if you're like out hiking, you could say that you hiked and you ended up 12 kilometers north of your starting point. That would nail down your displacement. Definition wise, scalar distance is literally the length of the path you've traveled. Or displacement, it's a little bit different. Displacement is the arrow or the vector, the line that connects your very starting point to your ending point. They're subtly different. I'll do a quick little picture to show you how they're different. But first, scalar distance, it's got the short form of the letter D. Vector displacement, it's also got the short form of the letter D, but to differentiate, we put a little vector head on top of it. So I draw a little half arrow. If I type it, it's just going to be a bar, or sometimes textbooks just bold it. So a D that's bolded means displacement. A D that's not bolded means distance. Let's say on my walk to school, I walk down one street, and then I turn and I walk down another street, and I get to school. The distance that I've walked, if I've started my if I'm in my car and watch my odometer, or if I watch my step counter, my distance is just add up the numbers. How far did I go this way, plus how far did I go that way? That's what my distance would be. Displacement's a little bit weirder. Displacement means connect your very, very starting point to your very ending point. So my displacement would be that. If it's nice and rectangular like that, I might have to do Pythagorean theorem to do the math. And displacement requires a direction, so I'd always, we'll practice this, but always get the angle that's closer to your starting point. Get that angle, and that tells me how many degrees away from straight north I actually moved. My displacement vector is pointing. We're going to pause there so that my videos aren't too long, and we're going to come back. This was just the how far, but we're going to come back and I'm going to add to the video, and we're going to talk about how fast.